What if you could build the most powerful AI in the world without ever actually seeing the data it learns from? I know, it sounds completely impossible, right? But that's the core idea behind a technology that's quietly changing everything, from medicine to the phone in your pocket. It's called Federated Learning, and it's here to solve one of the biggest paradoxes in tech today.
So to really get why this is such a big deal, you have to start with this basic truth. For modern AI, data is, well, it's everything. It's the fuel. It's what lets us discover new drugs or makes our phones smarter. But what happens when that fuel, the most valuable fuel, is locked away?
You see, the most important data, we're talking about your medical records, your financial history, is, for very good reason, completely locked down. It's trapped in these secure silos protected by crucial privacy laws like HIPAA and GDPR. And that creates this massive problem. The very data that could build the next generation of AI is the same data we can't and shouldn't ever share. So how do you build a smarter world if you can't get to the smartest data?
And that, right there, is AI's big privacy problem. How do you train an algorithm on information you're not even allowed to look at? For years, this just seemed like an unsolvable puzzle. But this is the exact problem Federated Learning was born to solve.
The solution basically flips the entire old way of doing things completely on its head. For decades, AI worked by moving the data to the computation. You'd gather up all the information in one central place and train the model there. Federated learning does the exact opposite. It moves the computation to the data. Instead of your private info being sent to some server, the AI model itself travels to your device, learns what it needs to, and then leaves your data right where it found it.
So what this really means is you can have, say, a dozen hospitals or even millions of cell phones all collaborating to train one powerful shared AI model. And the big breakthrough? Their raw, sensitive data never moves. It's never shared, never exposed to anyone. It's a system that's private by its very design.
Okay, I know. It still kind of sounds like magic, right? Training an AI model without ever laying eyes on its data. So, how does this whole federated process actually work? Let's break it down.
It all happens in this repeating cycle. First, a central server creates a kind of generic starter AI called the global model. Then it sends a copy of that model out to all the participants. Let's say it's a group of hospitals. Each hospital then trains that model on its own private patient data, just for a little bit. Now, here is the crucial part. They don't send any data back. Nope, they only send back the mathematical lessons the model learned. These are just anonymous model updates. Finally, the server takes all these lessons from all the hospitals, averages them together to create a new, smarter global model, and then the whole cycle starts all over again.
Okay, so the theory is pretty impressive. But what does this actually mean for you and me in the real world? Where is this technology really making a difference and unlocking AI's true potential? Well, the applications they're just staggering, seriously. We're talking about AI that can spot diseases on medical scans by learning from a global network of hospitals. It can speed up drug discovery by letting rival labs collaborate without sharing secrets. It can even spot financial fraud by learning from patterns across different banks, all of it done without ever compromising sensitive customer or patient data.
And this gets at a benefit that's even bigger than just privacy. Think about it. An AI trained at just one hospital is going to be limited by that hospital's specific patients, its specific equipment, but a federated model, one that learns from 50 different hospitals all over the world, it becomes so much more robust, more accurate, and way less biased. It's not just learning more, it's learning from a much more complete picture of humanity.
And hey, this isn't just a nice theory. The results are real, and they are measurable. Just look at this chart from a Grenze Scientific Society study. The federated model's performance absolutely crushed the traditional centralized model. By learning from all that distributed data, it became way more powerful and accurate. This isn't science fiction. This technology has already saved lives. During the height of the COVID-19 pandemic, the Basque Health Service in Spain used a federated model to predict which hospitals would need more ICU beds. Because it could learn from data across their whole hospital network, the system gave them a heads up, and as their director said, it helped them get the necessary resources ready before the surge hit.
But, no technology is ever a perfect solution. While federated learning solves this huge problem of data privacy, its very nature, being so spread out, creates a whole new class of security risks just hiding beneath the surface.
The best way to think about it is like this. The castle, that's your private data. It's secure, the walls are high. But the messengers carrying those lessons back and forth between the castles, they can be attacked. So while a bad guy might not be able to steal the data itself, they can absolutely try to corrupt the messages the AI learns from.
And these threats are pretty clever. A poisoning attack is exactly what it sounds like. A bad actor intentionally sends corrupted updates to poison the global model. A backdoor attack is even sneakier. They install a hidden trigger, like a secret command word that makes the AI fail when they want it to. And then you have inference attacks, where attackers play detective, trying to analyze the model updates to reverse engineer the private data they came from.
The entire system really becomes a battlefield. As you can see here, attackers can strike at a bunch of different points. They can poison the data on the device, they can intercept the updates while they're in transit, or they can analyze them once they get back to the server. It's a whole new set of worries.
And the impact of a successful attack? It can be absolutely devastating. This graph shows what happens to a model's accuracy during a poisoning attack. With just one malicious person, performance takes a hit. But add just a few more, and the model's accuracy completely plummets, making it totally useless. The whole system can be sabotaged by just a handful of bad actors.
And on top of those active attacks, there are just some massive logistical hurdles. System heterogeneity just means you're dealing with all sorts of different devices. Some fast, some slow, some with spotty connections. But even tougher is data heterogeneity. That's the fancy expert term for the fact that everyone's data is different and messy. One hospital might have 10,000 records, another has 100, and they're all in different formats. Trying to get one AI to learn from all that chaos is a monumental challenge.
So where does all this leave us? Look, federated learning is, without a doubt, a monumental leap forward. It unlocks the potential for AI that's better, fairer, and dramatically more private. But it is not a silver bullet. It's a new frontier. And on that frontier, there's this constant, high-stakes battle being waged between innovation and exploitation. And as this technology moves out of the research lab and into our hospitals, our cars, and literally the phones in our pockets, it leaves us with one really fundamental question. Can we innovate faster than those who are trying to exploit it? The future of a truly private, intelligent world really does depend on the answer.